Hi everyone. Today we're going to be learning about something called dimensional analysis. But before we do that, let's take a look at a quick little video. This is an animation of something called the Mars Climate Orbiter. And what it was a spacecraft that we made around 1998 to send to Mars so that it could measure the climate of Mars. And the whole project cost more than $500 million. And unfortunately, as it was landing on Mars, it crashed and burned. And my question for you is, why? What caused the crash? So here are three reasonable options. First of all is the autumnal equinox. B would be intelligent life on Mars. Or C would be King Henry I. So think about that real quick. And surprisingly, you could kind of blame this on King Henry I. How is that? His foot. I don't know if you're aware of this, but supposedly the unit of measurement called the foot comes from the length of King Henry I's foot. They wanted a good way to measure things, and they said, well, the king's foot will work the best. So some of the scientists have been using the English units of measurement based off of that, and other scientists have been using the metric system. And since they didn't write their units down next to their numbers, the computer system got it all mixed up, and this is why it actually crashed, and we lost the $125 million orbiter, not to mention all of the money spent to send it up there. So what is the moral of this story? Units, units, units. Every number in chemistry must have a unit written next to it. Never, ever, ever write a number without a unit next to it. Believe it or not, this will help you, I promise. We're about to learn a fantastic tool for converting from one thing to another. It's actually very easy once you get the hang of it, but it only works if you write a unit next to every single number. Let's get started talking about dimensional analysis. Dimensional analysis has another name. Sometimes you'll hear it called the factor label method. But here's the definition down here. Dimensional analysis is a problem-solving technique, and it relies on the fact that any number or expression can be multiplied by the number 1, and it still equals the same thing. 5 times 1 is still 5. 10 times 1 times 1 is still 10. You understand? It's actually pretty straightforward. Now you might be wondering, how is this actually going to help us out? Well, let's think of some creative ways that we could think of the number 1. What's any number divided by itself? 1. What's anything divided by itself? 1. And so we're going to be talking about this thing called a conversion factor. And a conversion factor is actually a fraction. Can you think of a conversion factor that you already know? You might already know that 1 foot, to stick with King Henry I, 1 foot is equal to 12 inches. That's a fact. So what if we were to turn that into a fraction? And we'll put 1 foot on top, and we can put 12 inches on the bottom. So what is this fraction equal to? Well, we have 1 foot, and it's being divided by the same thing, 12 inches. Anything divided by itself is 1. So this is a great example of a conversion factor. It's something that we can use to convert from one thing to another. We're going to be using conversion factors to cancel out things we don't want while we are converting. So here are a couple examples of conversion factors. There are 12 donuts in 1 dozen. Notice how I wrote that as a fraction. What would that fraction be equal to? 1. There are 5,280 feet in 1 mile. That is the length of 1 mile. And you'll want to remember that one for later this lesson. Here's another conversion factor. There is 1 mile in 5,280 feet. Now I know what you might be thinking. Aren't these the same? And they are the same. They're both equal to 1. But sometimes we're going to need this one, and other times we're going to need this one. And I'll explain how that works in just a bit. So there are just 3 examples of conversion factors. You can probably think of a lot more. So let's move on. How can I figure out which conversion factor I need to use? Well, there's a really easy trick to this. So let's say you have 30 inches and you want to know how many feet this is. And you know that you're going to need to use some fraction, which I have hidden behind this little question mark thing. Now, what does this fraction need to have? It needs to have one unit on the bottom. It needs to have another unit on the top. And how do I get things to cancel out in a fraction? You might know that anything on the top of the fraction and the bottom of the fraction can cancel out. Because if it's on the top and the bottom, you're dividing it by itself, and that's equal to 1. So I'm going to give you 4 options here, and go ahead and pause your video and figure out the most reasonable conversion factor to use. And this is the conversion factor that belongs right there. Okay, we can go ahead and rule out some silly ones. Since we have inches and we want feet, this conversion factor does us no good at all. There are 12 donuts in a dozen, that's true, but it doesn't help us. It doesn't help us here. Haha. Okay. 12 months in a year, also not so useful. So hopefully you narrowed it down to B or C. And you might have been a little bit confused as to which one to use because they look awfully similar. And they are. They're all equal to 1. All of these things are equal to 1. But there's one of these that's going to work better than the others. How can you figure it out? Well, do we want inches to be in our final answer? Remember, we have inches right now. Do we want inches to be in our final answer? No. We want our final answer to be feet. So think about where feet need to be in your conversion factor. I think that they should be on the top. Likewise, we have inches in our answer right now, but we don't want it in our final answer, so how can we get rid of it? By putting inches on the bottom. So look at this. If we put inches on the bottom, the inches go away, and we get into the unit we need, which is feet. And now we can just put the numbers in, and we know that there are 12 inches in 1 foot. So how would I actually come up with the number for this? Well, it's very easy. I look at all the numbers that are left. I'd take 30 and I'd divide it by 12 to get my final answer. But the more important thing getting started is getting the units in the right place. So the unit you need to cancel always goes on the bottom of the next fraction. The unit you need to get rid of always goes on the bottom of the next fraction. It's actually a pretty easy trick once you get the hang of it. Let's write down the steps of dimensional analysis to help you out if you get stuck. And you might need to pause as we go through these. Step 1, identify what is being asked. And I like to have you underline that because usually it's in a word problem. Underline what is being asked. Step 2, for example, if we were asking how many inches are there in 3 feet, what would you underline there? How many inches? And that way you can go back and look at the problem and immediately see what it's asking for. Step 2, what is given? For every problem you have to be given some essential information. What were you given in this example? You were given the fact that there are 3 feet. I have 3 feet. Step 3, what formulas or conversions am I going to need to use? Can you think of a really important conversion factor here? That's right, you're going to need the fact that 1 foot is the same as 12 inches. There's our conversion factor. Step 4, set it up and execute the calculation. And let's skip over the steps for step 4. We'll come back to step 4 in just a minute. And then step 5, check your answer, check your unit, check for common sense. Let's talk more about step 4. Here are just some strategies you can use when you're actually trying to set it up and execute the calculation. So more on step 4. Write down a unit next to every single number in every single step. I know it seems like a lot of work, but this will actually help you not make a mistake. Use conversion factors to cancel out the units you don't want. So remember, if you have a unit in the numerator, the way you get rid of it is by putting the same unit in the denominator of the next fraction. Remember, you might need to flip the conversion factor. When units show up in the top and the bottom, cancel them out. And I like to mark one line through it so you can still see it, but you know that it's gone because you canceled it. And make sure that the only unit you have left at the end is the one you wanted. If you end up with too many units at the end, you probably made a mistake, and you need to go back and check your work. All right, so let's try a problem. Which dimensional analysis setup shows how to convert 3,456 feet to miles? So let's go back and follow our steps to dimensional analysis. Step 1 says identify what is being asked. So what is it asking for here? Good, it's asking for how many miles. Step 2, what is given to you that you're going to need to use? And that is the fact that we have 3,456 feet. Step 3, can you think of a conversion factor that you're going to need to use? And the conversion factor we're going to need here is the fact that 1 mile is 5,280 feet. And of course, we're going to turn that equation into a fraction. So step 4, how do we make this work? Well, I've given you some options here. So at this point, I'd like you to pause and see if you can find the correct answer. Maybe you should try eliminating some incorrect answers first. So go ahead and pause and look for the correct dimensional analysis setup. All of these look correct, but only one is actually the correct one. Okay, so hopefully the first thing that you looked at is this conversion factor over here. And they all look very, very similar, but two of them have something in the wrong place. And I think that that is right here. Are there 5,280 miles in 1 foot? And the answer is no. So in that one we have our numbers backwards. I think there's another one with that same problem. So maybe we set up the units correctly, but the numbers are in the wrong place. So we can rule out A and C. So let's take a look at B and D. They both start correctly. They both start with what I'm given, which is the 3,456 feet. And let's double check the conversion factor. Are there 5,280 feet in 1 mile? And according to my equation over here, yes, that's true. Same thing down here. There are 5,280 feet in 1 mile. So can both of these be correct? And the answer to that is no. And let's take a look at B. What unit would I get here for my final answer? So I have feet in the numerator, I have another feet in the numerator, and I have miles in the denominator. So feet times feet over mile, feet squared over mile. Have you ever heard of that unit before? I haven't, because it's not the correct unit for length. Let's take a look down here. Here we had feet in the numerator, but we put feet in the denominator, and what happens when we have something on top being divided by itself on the bottom? Feet divided by feet, that's equal to 1. They disappear. They cancel each other out. And what unit do we have left? Well, that's the mile. So D would be the correct setup here. We start with 3,456 feet. We divide that by how many feet are in 1 mile. So looking at step 5, we always want to check our answer for common sense. When we get a wacky unit like this, that's a really good sign that our answer is wrong. Let's try another one now that's not multiple choice. How many minutes are in 1 year? So I'll get you started on this one and then let you finish it on your own. First of all, what is it asking for? How many minutes? Step 2, what's given to us? Well, we have 1 year. And usually, whatever is given to us is what we're going to start out our fraction with. So we have 1 year, and our goal is to get that into minutes. Step 3, what are some conversion factors we're going to need? Well, I think you know the relationship between years and days and hours and minutes, etc. So we're going to be using all of those here. Your job is to put them in the right place. So step 4, let's set it up and solve. And remember, the way we solve a dimensional analysis problem is by getting rid of the units we don't want. We don't want years to be in our final answer. Where does it need to go? Hopefully you said that years would have to be on the bottom of this next fraction. I love dimensional analysis because even when you get stuck, you have a good idea of what's coming next. You need to get rid of a unit you don't want, and the way to get rid of that unit is by dividing by the same thing. That way years can cancel. Can you think of a relationship between years and anything that will get us closer to our desired answer of minutes? And hopefully you said days. We know how many days are in a year. We know that 1 year has 365 days. Let's ignore leap years. So see if you can come up with the next fraction to use, keeping in mind the rules that we just talked about. Good, so days would need to go on the bottom. And how many hours are in a day? We know there are 24 hours in one day. And I just committed a simple mistake. Well, not a mistake really, but I really would suggest as you go, whenever you see a unit on the top and the bottom, cancel it out. It's gone. It's equal to 1. You don't need to worry about it anymore. So rather than waiting till the very end, I would cancel them out as you go. So now we have hours, and we're closer to our final answer. So go ahead and finish this up on your own, and get out your calculator and see if you can figure out how many minutes are equivalent to 1 year. Okay, so we know we have hours on top, and we don't want hours in our final answer, so this unit, hour, would need to go on the bottom. And we know how many minutes are in an hour, and we know that in 1 hour there are 60 minutes. And we can cancel out the hours now that it's on the top and the bottom. And the great thing about dimensional analysis is you don't need to guess anymore what the unit is. Maybe you're used to in math class doing all the math and then tacking on a unit at the end and hoping it's the right one. But with dimensional analysis, you know, because it's the only unit you have left, minutes. It's also a great way to tell if you've done something wrong, because if we got something wacky here, like liters, that's probably a mistake, because liters is not a very good unit for time. So how will we actually find out our correct answer here? Now that we've taken care of the units, now we get to look at the numbers. And it's very simple. We're going to multiply all the numbers in the numerator, 365, 24, 60. We're going to divide by all the numbers in the denominator. And I know what you're thinking. Well, there really aren't any numbers in the denominator that matter here. So in your calculator you would do 365 times 24 times 60. And when you do that in your calculator you get 525,600 minutes. And that is one annoying song, let me tell you. Here's a tougher example. Let's say my car gets 27 mpg, miles per gallon. And let's say gas currently costs $3.66 a gallon. How many miles could I drive if I just have $5 to buy for gas? So this is a much trickier problem, because there's a lot of things in this word problem that you have to pick out. So let's follow our steps. Step 1, what is being asked? And hopefully you just underlined in your notes how many miles. That's what it's asking for. Step 2, what is given? Now, a lot of things are given here. Let's see if we can rewrite them. 27 mpgs. What does mpg mean? Miles per gallon, miles for every gallon. That kind of sounds like a conversion factor. 27 miles for every gallon. $3.66 for every gallon. That sounds like a conversion factor too. And there's one more number in here that's given to us, $5. Does that sound like a conversion factor? So 2 of these are conversion factors, and one of them is just a plain old number, $5. Which one do you think it's best to start with? In this case, we want to start with $5. So, this is a tricky one. I'd like you to pause and see if you can sort this out. Remember, sometimes you need to flip a conversion factor. The number stays with the unit that it's already next to. When you flip a fraction, you just flip the numerator and the denominator, not just the numbers. Remember, you put in the unit on top is the unit that needs to go in the bottom of the next fraction. So go ahead and pause this and see if you can come up with the correct answer. Okay, well, what I want to do is skip ahead and show you, maybe you did this without units. Maybe you thought you could be a little bit faster about it. Let's say you did it without units. Well, what are some of the wacky units you get? If you had used your units and you answered A, you got dollars squared times miles per gallon squared. Does that sound like a reasonable answer for how many miles you can drive? No. Gallons squared per dollar squared mile. So we can see really quickly that by using our units, there's only one of these choices that gets us anything reasonable. But let me go back and actually finish the problem now. So $5, and reminding ourselves, I want to figure out how many miles I can drive with that. The first thing I need to know is how much does a gallon of gas cost? And normally we say cost per gallon. How many dollars is it per gallon? But here we need to be a little strange. We need to say 1 gallon has a cost of $3.66. Why did I flip it? I flipped it because I had dollars on top already, and I need my dollars to go on the bottom so I can cancel them out. So now dollars are gone, and I have gallons. And I'm trying to get into miles, so I need to know how miles relate to gallons. And remember, my car gets 27 miles to the gallon. 27 miles for every gallon. Do I need to flip that conversion factor? And the answer is no, because I need gallons to go on the bottom, so they'll cancel out the gallons on the top, which means that miles goes on the top. And for every 1 gallon, I can drive 27 miles. Do I get to cancel out a unit now? Sure do. Gallons are gone. Am I ready for my equal sign? Do I have the unit I expect and no other units? Yeah, I've got miles. So I can write equals, and I know that my answer is in miles. And now with my calculator I can actually figure out what the correct answer is. So in my calculator I would type 5 times 27 divided by what? 366. 5 times 27 divided by $3.66 gives me my answer of 37 miles. So if I only have $5 to buy gas, I could drive a little under 40 miles. So you might be a little bit confused right now, and that's okay because dimensional analysis requires practice. But I promise, once you get the hang of it, it's very, very easy, and it is so useful. It will prevent you from making mistakes. It's actually pretty fast once you get the hang of it. So you'll be practicing this in class soon. Thanks. Bye-bye.